Okay, we're continuing our study of the sphere, and what have we said so far? We have said that the volume of the sphere is 4 over 3 pi r cubed, and we've looked at that here and said, well, an r cubed is a kind of a cube which would be a bit smaller, and we've roughly said that's the same as 4. Now, if we wanted to know more exactly, we would just calculate, we would put the 4 pi on the top and the 3 below. 4 shift pi over 3, and we could just go shift equals to see it in decimal. So now you'll never get it exact, you can only write down loads of those figures, but we could say more exactly 4.2 of these. If this is repeated 4.2 times, we're very, very, very close to getting the full volume of the orange, and in particular 4/3 of pi r cubed gives us the volume of the orange. Now we've gone on to see where did this equation come from, 4 pi r squared, and we are literally studying the anatomy of the equation, and in anatomy we chop things up. So let's chop the orange up. Okay, no animals were damaged during the making of this video. There we have the, what's it called? The maximum cross section of the orange. Okay, and what could we model that as? We could model it as a circle. And the orange smells lovely. And we're going to have coffee in a minute, and you'll see how it connects with the lesson. Because this is a sphere too, more or less. We're going to talk about that. So we're going to have coffee and oranges. Okay, so, and we've drawn, put that aside for now. So yeah, we get the idea, I hope, that the orange cross section repeated once, twice, trying to make sure I don't run off the bottom of the page. Problem solving is at the center of everything we do. Let's do better than that. Let's say we'll touch them both, try to touch them both exactly in one place. Let's put that there. No, I need to, okay, roughly, I don't have to anyway. Okay, I don't have to touch them both, so that's for another day when we're doing constructions. Okay, so we've 4 pi r squared. Each one of these is pi r squared, this thing. I'll show you 2 of them right now, but I need to cut up another orange, the equivalent, and you don't need to. You get the idea? So it's pi r squared, pi r squared, and pi r squared. Now, I'm going to get messy, but what that formula is telling us, 4 pi r squared, is that if I peel the orange, now I don't know if you want to see me eat this on picture, off picture, but it's going to happen. Oh, that's lovely. And I squeeze it out and cut it up and everything, that I'm going to end up with enough orange, because this is the surface area, to cover all 4 of them. I made my circles too big, so we're going to shrink them just to make the point. I don't have to eat it, you know. I'm going to talk if I eat it. That's okay, because we're just getting the orange. What a mess. Okay. Go again. With a smaller circle, which more exactly matches the orange in the first place. Okay, and of course I can chop this up so that I can make it fit, and if I make all the pieces very, very small, infinitely small, I will be able to chop up my orange. And I'm sure you're laughing at me now thinking, God, I'm making a mess of this. Scissors, really. Which, don't worry, I have a scissors. I'm pretty sure I have a scissors. Now, the practical side of it is the challenge. It'll be a fantastic exercise to take the real spirit, especially at junior cert, of 21st century skills, is to get you to make a video doing this, and it'll be a brilliant CBA. Okay, so I'm trying to fill up all four. Got most of my orange now on the scene, and I'm going to ask you to agree with me that I filled up 1, 2, 3, 4 of my circles. So I want you to be convinced that 4 of my circles fit within my full surface area of curved surface area of the sphere, or the orange in this case, makes up 4 of the cross-sectional areas from the middle of the orange. So I'm going to keep that, take a picture of it and post it with the images in Google that go with this video in Google Photos. Okay, that's our sphere done. So now we're going to work through the examples in the book, and but just before I do, just to say, because I want some coffee, just to say that, and I know I might have skipped a page there, but volumes can be made equal to each other. When we're problem solving, I'm making a mess there with spilling it. I can go and I model this coffee as having been in a sphere, and now it's in a cylinder, my cup. Lovely. And we'll be able to connect the radii and do calculations based on the different radiuses and the different measurements and heights and so on in cylinders. So they will become a big part of what we're about to do. Okay, so let's push on with it now. We're always going to get the volume and the surface area in terms of pi, and then we're going to always truncate to 3 figures and round to 2 decimal place figures. Okay, so let's proceed. So they want to calculate the volume. We're going to write down the formula for the volume. 4 over 3 pi r cubed. Now remember that image of that cube that I had. That should help you remember it. 4 over 3 pi r cubed. By the way, just think, what would half of that be? Oh, look, silly me. I've gone and used this sphere formula, not the cylinder formula. So let's just cross that out. That's okay. We make mistakes all the time and we fix them. So the sphere formula was pi r squared, the area of the bottom of the sphere, multiplied by the height of the sphere, h. Okay, now in our case the diagram's already done for us, so we're just going to go pi multiplied by, on our calculator, 5 squared multiplied by 12. Okay, and that is, I'm going to go 25 times 12, and I'll say times pi, because I know what the calculator will do. It will write it with the pi. Okay, you always want to write that down. Get into the habit of it. Don't be just dealing with, when we're doing the questions, we're just going to have a recipe that we always do this. Okay, so the volume is that. Now you do shift equal to get your approximation. You can do that on any of the three calculators. Okay, this is the old, but it works on the new and it works on the old as well. Okay, so 300 pi, and when you do that shift equals, we're always going to say equals and go 942.477 dot dot dot. We'll put three significant figures, and then it's always three dots to say that I've been truncated, I haven't rounded. That's what that means. Okay, and then we'll say it's approximately 942.48. okay, then we look at the units and say that's centimeters cubed, and by the way, this one is centimeters cubed too. Sometimes that'll be the answer in terms of pi, sometimes that'll be the answer if they wanted to decimal places in terms of units cubed or centimeters cubed. Okay, now for the area, and we need to see that it is total surface area. So total surface area, you can open your log tables and write it down, and I suppose the only thing to be particularly about is not to do what I just did. Now that mistake I made is really good, because we're not going to make it again. You know what I say, fool me once, shame on you, fool me twice, shame on me. So I made a mistake once, I'm not making it again. So I'm up here and I'm looking at this and I'm writing down the area. Now I can write it down from memory because I really know it and understand it, and that's where you're aiming to be. But for a while you might want to look it up, but do remember that the long length or the length that's associated with this is 2 pi r, so that's why that's there. And then you have the height of the triangle, of the rectangle that you've opened out, which is h. Okay, and then you also have plus the two circles, so the one circle would have an area of pi r squared, and you need two of them. Okay, we can take out the fact that the 2 and the pi and one of the r's is common. We can make our calculation a little bit easier with 2 pi r times the r and the h. Now that's absolutely lovely. You're going the radius and the height, so it's almost like a half perimeter calculation if it was a 2D thing. Okay, so, and we've seen that half perimeter many times before. Okay, so excuse me, that makes it quite easy. Look, you saw me eating the orange, so you know that's why I'm burping. 2 pi times 5. I'm just going to leave it. I know I'll have to be careful with the calculator, and then I'm going to write in brackets here 5 and 12 is 17. Now when it comes to the calculator, of course, now what I have is I have 10 times 17 is 170, so I can do that straight away. 170 pi. Okay, so that's what you'll get when you do all of that long bit, this bit, or if you do it with this trick. Now what I'm going to do is I'll put the 170 pi in the calculator, or just to be sure, I'll go 2 times 5 times pi times 17, and we'll see what it is, and then I'll do my shift equal, and I'll say the area equals 534.070 dot dot dot. If we're going on and on and on, we're not looking and deciding there. That's what makes that really quick. And then we say area is approximately equal to 534.07. okay, and that's obviously rounded. You can put this 2 decimal places, but because you've put this, you don't have to, so it makes it a bit easier. And you put in your units, centimeters squared. Same here, and that's that question done to a very high standard, and we've set the scene for what we're going to do. Okay, we're going on to example 2 now, and the trick here is, so I'll do this more specifically, not do out everything. So the volume of the cylinder, so we'll write down V equals 15840, because V is the letter we use for volume. Okay, we're still on the cylinder, so I'm being careful not to confuse myself with down here. So we have pi r squared h. But before I do that, I also want to come over here and emphasize that we know the 35. And so I'm going to write down everything we know gets written down. It's like a table of stuff we know. So the H equals 35 and the R equals question mark. Now comes the formula. The formula for V is pi R squared, the base, times the height. Okay, but we know the height, and we know lots of this stuff, so we're going to fill it in. So what we're going to do is we're going to say pi, 35 pi even, because this 35 can go in front of the pi. So 35 pi R squared equals 15840. Okay, now before I go near that, we're doing now what's called in your book make the subject of the formula. So we're trying to make R the subject of the formula. So we begin by saying, look, there's an R in there in that factor. So the first thing we want to do is get the factor that contains R on its own. So that means we're going to inverse operation this, which means divide it down. Okay, so we have R squared equals 15840 over 35 pi. Okay, now we can start messing with our calculator now, or we can stick with the important maths. This is a square with R as its side, and the area here is this. So to go from a square, like say I knew there was 9 was the square, then I'd say, hey, 3 is the side. We do the square root. So we do the square root of the left, and we do the square root of the right. This is a nice thing to do at the end of your square root. It's just to say, it's to show that you finished. If there's lots of stuff in there, like there is sometimes when you're doing statistics and getting the standard deviation, say. 35 pi goes there. Okay, and we have our R equals this. Now you take your calculator and calculate it. So just to recap before we do that, we have started with an expression with R squared in it with all the values filled in. We isolated R squared by dividing. Okay, and I want to write down what we did here. We got R by inverse operation of the square. So the inverse of the square operation. Now when I said the word operation, you're used to the words operation for this, 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 and this. But the square is an operation too, and its opposite is the square root. Okay, because I can put down any stupid number there and square it, and then I can square root that answer, and I get back to where I started. You could do one yourself. Why not just try this one? 147258. You agree that's a crazy big number. You could square it. That's even bigger now. Let's see. Square root that answer. 147258. Excellent. Okay. So so that's what I'm doing, and the inverse of square is square root. I've been noticing that a lot of you don't know how to say it. Okay? So you've got to learn this off. We were doing a thing in class where we have a visual of a square and a root under the ground. Now I need to figure out how to do my tree a bit better, or how to a better way to draw a root, but it's a square root. So we square root both sides. So when it all comes down to it, we just go to our calculator, hit square root, hit fraction bar, because we have a fraction in here. We're going 1580. 15840. Now, I continually also talking to you when you say, oh, I didn't get the right answer, not quite, and then we should look at what, on our calculator what it said. Even after saying equals, it still says what we put in, and when we look at our calculator we notice we typed it in wrong. Okay, so be very careful to look and make sure we've typed it in right. And the answer is 12, the radius equals 12, and the units based on what we've been given here are centimeters. How's that, lads? That's example 2 done. Okay, and here's my where I was supposed to pour my coffee. So I'll ask you to pause the video now and read that yourself. You read it? Great. You're back. You did pause now, didn't you? You didn't just keep playing and say it's going to be read for me. Okay, it is going to be read for you, but just this time. If the two volumes of two different shapes, my sphere for my coffee, if it was full to the top, and my cylinder, regardless of whether it's full to the top. Now I'm not going to turn my cylinder on its side for obvious reasons, because the coffee will go all over the place. But I can turn this on its side and tell you the coffee only goes up so high, but a cylinder always remains a cylinder no matter what height, as long as you use the height. Unlike this, so I'd have to model this of having been full and emptied in fully. But anyway, if the volumes of two different shapes, now I am a little bit upset they used the word shapes here, and I'll show you why. On the specification, which is gone over here, is it? Remember I showed you the specification a minute ago? I gotta have to clean up how I do this. I gotta get a better system. But here it is. Well, that's an old one I was showing you. Mind you, it would do, because they use the word shape for 2D and solids for 3D. That's why I'm upset, because they could have been more careful, like we were when I asked you to take these down. So we talk about 2D shapes and 3D solids. You see, I really take the English really, really seriously. And I was a little bit behind writing my own things. So if the volume of two different solids are equal, we write down the formula for the volume of each solid and then equate the two volumes. Equate the two volumes, that was your pause, that was your equate. You put equals and you put the formula and the numbers on each side. This enables us to get an unknown dimension, like a radius or a height, in one of the two solids. Okay, here are some examples of equal volumes. If liquid is poured from one shape into a container of a different shape, my mug, of a different solid or 3D shape, because they're hollow, the volume of the liquid remains the same. So when I pour, now I've been drinking it, but that's different. When I pour my coffee from one container to the other, there's no coffee disappearing. Not until I drink it anyway. Okay, so during the pouring, it stays the same. That's kind of obvious, isn't it? And if a solid object is immersed in water or coffee, now I could start dropping solid things into this, like a piece of orange. We do it. What's going to happen to the level of the coffee? Hopefully it's not going to overflow. The orange sinks down and the coffee comes up. There it is, just poke it, just almost floating. We drop in another one and you see the liquid is coming up and up and up. Now my coffee is going to taste of orange. Anyway, we get the idea, and we're going to have examples like that as we work through. Okay, that's quite a long video, so I'm going to pause it and we'll continue on then with example 3. I'll work down through it here. Okay, and we'll use this as a wonderful example for you to do problem solving, and then you'll do it again and again and again on your own, practicing and then you'll be able to do other questions very similar to it. You'll be able to apply your knowledge. As always, I will see you in the next one.